Yes, elasticity. If the external force producing deformation do not exceed a certain limit, the deformation disappears with the removal of the forces. Thus, the elasticity behavior implies the absence of any permanent deformation. Okay, what it means, Amma, if you apply the external force up to certain limit, okay, there won't be any accidents of the deformation. Up to certain limit, there won't be any accidents of the uh, deformation, and it will regain its original shape and size. Okay, and the deformation will be appear when we remove the load from that particular material. The deformation will be disappears from that particular material. Okay, so the elastic behavior implies the absence of any permanent deformation. You can't see any type of deflections or any type of permanent deformations in the material. It will comes to its original positions. And we can also define that one, the property of solid materials to deform under the application of an external force and to regain their original shape after the force is removed is referred to as its elasticity, the behavior of the elasticity. What they have given the deformation under the application of an external force. Okay, behavior of the material under the external force and after removal of the external force, how it will behave when it regains its original position after removal of its load. It will comes to its original position, and this behavior, this property is called as the elasticity. Okay, and you can say the external force applied on a specified area is known as the stress, while the amount of deformation is called as the strain. In terms of stress and strain, we can correlate with the term stress with load and area, and strain with change in deformation to virginal length. Okay, you can see here example, one rubber is there. Initially at before applying the load, it will be in its original shape. When we apply the load over this one, there will be some deflections. It will move towards the load. Okay, those from the both the sides, when we apply the load, the material will deflect inner side, and when you remove this load, it will regain its original shape and size again. Okay, this nature is called as the elasticity, and it is the branch of the solid mechanics which deals with the stresses and displacements in elastic solid produced by the external forces or change in the temperatures. Okay, this behavior we can see here, so this one is the branch of the solid mechanics. It has been correlated from the solid mechanics, and this type of materials deals with the stresses and displacement in elastic solids. In continuum bodies, the behavior of the stresses and nature of the deformations has been studied in this particular topics. Okay, in this particular subject. The purpose of the study is to check the sufficiency of the strength, stiffness, and stability of the structural and machine elements. We not only we use in structural elements, we used to use these all are in machines also. We used to get these parameters, strength parameters, and stiffness parameters, and stability parameters. We also correlate with the machines also, not only the structural elements, we used to correlate with the machine elements also. In machine elements, they also require the strength parameters and stiffness and stability parameters, as we take care of these parameters in structural elements also. Okay, theory of mechanics. What is the theory of mechanics, Amma? May be defined as that branch of engineering science which deals with the study of relative motions between the various parts of machines or structures. Not only the machines, there will be the relative motions between the various parts of the machines and the forces which acts on them. Okay, the deformation they used to correlate with the motions of the body along with the forces, how they are behaving under these particular forces. This one is called as the mechanics. This one is called as the machines, and these machines are also classified into two categories. We can see here different categories are there, but here we are discussing regarding two type of categories. One is the kinematics, another one is the kinetics. Okay, whereas the kinematic is the branch of the theory of machines, which is responsible to study the motion of bodies without reference to the force which are caused this motion. Okay, without reference to the force, without application of the force. Okay, with means there won't be any external forces will be there on that particular body. Okay, the motion of the body without application of any external forces, and this type of behavior we used to call as the kinematics. Okay, and that it's relate the motion of variables like which type of parameters we can see displacement, velocity, acceleration with the time which varies with respect to the time. For suppose if you take any earthquake forces, there we used to consider all these parameters displacement, velocity, acceleration. There we won't going to apply any continuous force, external force. There will be only the disturbance of the force will be there. Initial disturbance will be there. After removal of the disturbance, that body will keep on moves over a time period. Okay, the type of motions we used to call as a type of motions we used to call as a actually dynamic forces we used to call, and free vibrations we used to call, and those type of vibrations generate some displacement, velocity, and acceleration with respect to time, and those type of behaviors we used to call as the kinematics. Okay, that all those all are will be dealt with the kinematics. And whereas the kinetic is the branch of the theory of mechanics which is responsible to relate the action of forces on bodies to their resulting motion. Okay, when we apply the force over a body, it will give uh, for suppose if we apply the forces from the different directions over the body, and the stresses will be generated in different direction in the direction of the forces where you apply. Okay, and those stresses will be generated on those particular planes which you in normal to the force direction. Okay, if you apply different directions forces, there we can see the different directional stresses also, and not only the normal stresses we can see, we can also see the shear stresses over the body also. Okay, there we can see the shear stresses also. Kinematics is the deals with the bodies which has been related with the forces when we the displacement of the body when we apply in the forces on the body. Okay, action of the forces on the body, the resulting motions. Okay. Motion is here motion is nothing but displacement, velocity, and acceleration parameters. But in case of kinetics, we use to take displacement parameters in most of the cases. There won't be any time related motion. What is the important concept of theory of elasticity? To know this one, we have to know some of the parameters. Like when we apply the forces over the body, those forces will be applied in different directions, and stresses generated by those forces, which are nothing but internal forces we used to call, their behavior we used to study, and deformations which are dealt with the strain parameters. Okay. Here strain deformation is nothing but motion of the body, whereas the displacement is nothing but the dislocation of the joints. Okay. Deformations will be dealt with the deflections in the beams or the deformation of the bodies under the application of the loop. Whereas the displacements we can see the displacements in most of the cases we used to see at the joints, dislocations of the points we can see the displacement of the joint. Okay. Displacement we can see in the body itself, body also, but most of the cases for visualizations, if you see dislocation of the joint also we used to call as the displacement of the body. And what is the external force amount? There we can see two kinds of the external forces that acts on the body. Okay, what are those? One is the body force, another one is the surface force. Okay. Whereas the body force is related with the forces which acts along the natural forces like gravitational forces. If you see the gravitational forces, if you if you freely fall any body, okay, if any body is freely falling over a time period, okay, that moves towards the earth gravitational direction, okay, that motion of the body, the falling of that particular weight we used to call as the body which is acting along the gravitational field, and that force generated due to that gravity we used to call as the gravitational forces. That one is first one, and second one is the inertial forces, and inertial forces will be related with the mass of the body and direction of the force you have applied initially, okay. Every body is having some mass, and that mass will be, if that mass will be moves in any one direction, in that particular direction force will be generated in that particular body, okay. That inertial forces we used to call, for suppose if you take from your 12th standards, you can get that one, and also in your engineering mechanics you might have been studied with that inertial forces. Force D'Alembert's principle will be explains regarding the inertia forces, okay. Mass into acceleration, force is equal to mass into acceleration, that will be comes in inertial forces we used to use, okay. And second one is the surface forces, where we can see these surface forces. These surface forces which are acts along the surface of the body. For suppose if you dip any body in the water, the water pressure will be acts throughout the surface of that particular body, okay. Those pressures, those forces we used to call as the surface pressures, okay. For suppose if you take pressure in water and atmosphere, our body also experience exposed to atmospheric pressure, okay. That one is also called as the surface force, and the one is the pressure, another one is the contact forces. Contact forces, if you apply any frictional forces over the body or parallel to the parallel to the surface of the body, those forces we used to call as the contact forces. For suppose if you see in transportation engineering, when we apply the brakes over the pavements, the resistance is offered by the pavement to the tire of the that particular vehicle. Those type of forces we used to call as the contact forces. In our solid mechanics, in theory of elasticity, we used to use most of the bodies will be related to the solid bodies, and they used to have solid surface, okay. The resistance offered by those solid surface we used to take as the contact forces, and the external forces which we apply over the body is called as the pressure, okay. These forces we used to deal with we used to call as the surface forces, okay. For suppose if you take any continuum body and cut at section mm, if you take any continuum body, just consider a body which is having purely solid material. Here continuum is nothing but the body which is having with continuous solid nature, okay. There won't be any wide spaces in the body, there won't be any distractions, or there won't be any honeycomb in the body. You can't see any type of voids in the body. Those type of bodies, continuous bodies, we used to call as the continuum bodies. And if you take any continuum body, if you cut it at any location of this body, for suppose if you see here in this figure, M and N is a section of the body. I have cut this body at section M and N, okay, as shown in figure. And when I cut this body, I can see the area of this particular location, and I can see the forces applied over this body. You can see F1, F2, F3, F4 and F5. These all are the external forces which are applied over the body, okay. These all are the external forces which applied over the body. You can see here these two are the surface forces. These forces F1, F2, F3, these all are indicates the surface forces of the body. And whereas the body force will be acts, mass will be acts in the downward direction, okay. The mass of the body will be acts in the downward direction, which is the gravitational, or if you apply any force, there will be some inertial force will be there. That one is called, combination of those two we used to call as the body forces, okay. And whereas F1, F2, F3, all these forces indicates the surface forces of the body. All these are the external forces. When I cut this body having the some surface area A, okay, and it will be resist some forces, some stresses over this surface, and those surface we have to find in terms of stresses. Okay, and the small area, if I take to find out those stresses, I used to take a small element over this particular body, and this small element is having area of the cross section del A at a point O. You can see it here, this is the point O. Okay, I am taking a small element having grid type of element. You can see here, we can take here grid type of element, or you can take a circular type of element. If you take a grid type of element, it is having the area del A, and force taken by this particular element will be resultant force. Fn is nothing but the resultant force which is taken by this one, this particular material. Okay. Force F1 which is acting over this particular body, total force which is acting this body will be shown in this figure. Del F is the force which is taken by this particular body. And from this concept of the stresses, from the concept of the stresses, we used to take internal forces per unit area can be understood. Means this force has been applied over this particular element. This force is taken by this particular element, and this particular element is having the area of the cross section del A, and this correlation of these two will be gives us to a concept of stress. The force which is applied over particular area is gives us a stress. Assuming that the material is continuous, the term stress at any point across a small area del A can be defined by the limiting equations as given here. You can see limiting equations. Stress is nothing but the force over a area. Limits are del A tends to 0. As small as you can take a element, you can take that one as our resulting element. Okay, and that element is taking force del F, resulting force, external force which is applied by over that particular material, by that force is taken by that particular element which we have chosen. These two will be gives to the stress. Okay, and whereas the del F is the internal force on the area del A surrounding the given point. Okay, here you can see del A force which is taken by this particular material, my internal force which is resisted by this particular material. Okay, and it is acting over this force is resisted by this cross sectional area del A. Okay, this one is called as the stress. Stress is sometimes referred to as the force intensity also. We used to call it as force intensity also. And whereas del F is reflex resulting of the internal force, and we used to find internal normal stress sigma n, which indicates the normal stress of the body. Sigma n is equal to limits tends to del A, limits of del A tends to 0, which gives the del F by del A, which is nothing but the area stress which is normal stress which is acting over the particular surface. Okay, normal stress which is acting over the particular surface of the element which we have chosen. Okay, same things, internal forces which are produced by the external forces. As we see here, these all are the internal forces. Okay, parameters which are related to the stress, those all are comes under the internal forces which are produced by the external forces by application of the external forces. And third one is the deformation, where we can see the deformation when we apply the forces over the body will be try to deforms inside. If you apply internal forces above in the surroundings of the particular surface, the body will be try to move in inward direction. Okay, those deformation, those distortions or deflections of the bodies are called as the deformations. And strain components completely define the deformation coordinates or strain conditions at that particular point. These bodies will be defined by the deformation components, strain components that can be explained by using these deformations in those directions. And this deformation we used to indicate in terms of displacements, the change of the positions. Okay, we indicate as a displacement by changing their positions, the displacement components in 3 directions. Here we used to take most of the cases 3-dimensional bodies. in x, y and z directions, and the displacement in these respective directions we used to take as u, v and w. These are the displacements of the bodies we used to take in the as the related parameters, whereas the displacement of the strain related parameters. Okay. These three are the forces which we applied over the body. Okay. These three are the resultants and application of the four external forces, internal forces and strain which are developed inside the body. All will be dealt with the theory of elasticity. These all are the comes under the concept of the elasticity. Okay. Without these three parameters, we can't solve any problems in theory of elasticity. Okay, some of the basic assumptions are there in this theory of elasticity. What are those? The body is continuous. Body has to be continuous. There won't be any void spaces in the body. And second one is that the body is perfectly elasticity. Okay, the body should have perfectly elastic nature. Okay, it has the property of elasticity, where it may be a continuous, but it has to have elastic properties. The body is homogeneous and body is also isotropic. For example, if you take polycrystalline ceramic powder material, if you take that one, and steels, wood and fiber reinforced composite materials, any material, if you take any concrete material also, we used to assume it as a continuum body. Okay, it is a continuous body. Okay. The displacements and strains are very small. We used to consider as these displacements and strains which are generated inside these particular bodies will be very less. We used to consider they are very less, minute. Okay. These are the basic assumptions which we need to assume in the theory of elasticity. Notations of the forces. Before going to start any derivation, we used to know which type of notations we are going to use to show the indicate the forces. Here we have taken two kinds of the forces which are acting over the body. One is the body force. One is the body force, and another one is the surface forces. Two type of forces we have taken in this one. Okay, two type of externally applied forces will be body forces as well as surface forces. Okay, and these body forces and surface forces, they combined together, we used to indicate with the letter with different letters. Okay, it may be body force or it may be surface force. Whatever may be the force, we used to indicate with the we used to indicate with different type of letters. Okay, we used to denote with different letters. For suppose for body forces, we used to take as Fx. If you are applying the force, body force is in x direction, we used to take Fx in the body or surface force, any external force. Okay, these forces we used to indicate with the Fx, Fy and Fz. By depending on the directions, we used to apply with the notations. Whereas the surface forces will be acts over the body. Also indicate they also used to give the different result. These two will be we used to indicate with the different letters. We will see those. Okay, and surface forces also we used to indicate with the F1, F2, F3 as we have seen, and force distributed over the volume of the body, such as gravitational forces, magnetic forces, or in this case of the in the case of body in motion, if it is in motion like dynamics, and inertia forces we used to indicate. These all are called as the body forces. Okay. The surface forces per unit area we shall usually resolve into three components parallel to the coordinate axis and used for these components notations as x like not capital X. Here we used to indicate with the letters f of x, f of y and f of z. We used to indicate these components. One second. These are the body forces. Fx, Fy and Fz we used to indicate as a body forces. Okay, it will depends on condition. In different books they have given different notations. Okay, here we used to use f of x, fx, fy and fz for body forces. Force which is acting per unit volume, here we used to take as the body force. And we shall also resolve the body forces per unit volume into three components and denoted by the components by x, y and z directions. Okay, these are these are the notation for the forces, and similarly we used to take notations for the stresses also. Notations of the stresses. When resolve these bodies, if you take any element from that particular continuum, here I am going to take a continuum, a cubic element, like you might have been seen a Rubik's cube. One element of that cube will be shown this direction, this type of forces. When you apply forces over that particular body, and those forces will be shown as internal resistance offered by the material, like this. Whereas if you apply any external force, there you can see different notation. Those forces will be taken by the material, and that material will be having the some cross-sectional area. Okay, it will be have the cross-sectional area, and that particular cross-sectional area will resist all the forces. In some of the forces in parallel to the surface, and some of the external forces will be perpendicular to that particular body. Some of the forces will be parallel to the cross-sectional area of the body. Some of the forces will be perpendicular to that cross-sectional area of the body. And those forces we used to indicate with different notations. And we used to call these forces per unit area as the stresses. And those stresses also we used to denote in two types. Whereas if the force is normal to that particular cross-section, that one we used to call as the sigma letter. We used to indicate with the letter sigma, and we used to call as the normal stress if it is perpendicular to the cross-sectional area. And if it is parallel to if you apply the force over the area and it is resisted by that particular cross-section or particular area, that force is called as the shearing force. Okay, and that shear force will be gives the stress as the shearing stress, and that one we used to indicate with the letter tau. Okay, tau is the resisting shear stress of the body, which is given offered by the particular element. Okay, if you take a small element, cubic element, if you see here, a cubic element is there at a point O in this particular figure. Okay, with sides parallel to the coordinate axis, and the sides are parallel to the coordinate axis. You can see the side one in x direction, and two sides will be there. This body is having two sides, and sides along the y axis we can see two sides, and similarly z axis also two sides will be there. Okay, sides of the bodies will be there, and if you consider these sides of the bodies, how many sides we have? 6 sides for the three-dimensional bodies. Okay, for these six sides of these bodies, and its sides parallel to the coordinate axis. These sides are all the sides are parallel to the coordinate axis. The notations for y axis, for instance, okay, the normal components of the stress acting on these sides are called as denoted by the sigma y. Okay, if you apply any normal force over this surface of body, normal force is normal to the y direction, okay, parallel to the y direction, and which is normal to the plane of x and z. Okay, and that normal stress is denoted by the letter sigma y. If you apply the force, otherwise the body is taking the force normal to this surface, okay, cross-sectional area. If the body is taking the force normal to this surface area, okay, that force we used to call as the normal stress, and that one is denoted by, if you apply the force in the direction of y, you can get the stress normal to the sigma y. Okay, normal to the surface of xz, and that stress is called as the normal stress. Okay, that one is called as the normal stress, and this y also generate the some shear stresses along the xy plane and xz plane also. You can see here in the xy plane it will generate the xy shear stress, and also it will generate the yx shear stress, and here also you can see the zy shear stress, and also it will generate the zy shear stress in these planes. parallel to the y-axis, the force will be generate shear stresses also. Okay, these will be indicated with the letters tau xy or tau yx, and in the z direction tau zy and tau yz. Okay, shear stresses will be generated in these particular bodies. Okay, these all are indicators. These all are the notations. Sigma y, if you see, subscript of y indicates that the stress is acting on the plane normal to the y axis. The normal axis direction will be indicated by the y, and forces acting another two direction will be indicated by the x and z. The force which is acted in the direction of y, and it has generated shear stress in the x plane. Okay, in the direction of x, and same thing y, force applied in the y direction and shear stress generated in the z direction has been indicated in this particular notations for the shear stress cases. Those are the notations. If you see here, a single suffix for notation sigma, like sigma x, sigma y, sigma z, is used for the direct stresses, and double suffix for the notation is used for the shear stress, like tau xy, tau xz, h. We can see for the two dimensional tau xz, tau yz, and you can see tau yx also, and tau xx, tau yy, tau zz, which are nothing but normal stresses we used to indicate as the sigma x, sigma y, sigma z itself, and those can be indicated like that also. And tau xy means a stress produced by an internal force in the direction of y acting on the surface having the normal in the direction of x and z. Okay, normal in the x. The definition of tau xy, it has been indicated here. Internal force in the direction of y acting on the surface having the normal in the direction of z. Okay, surface will be in the x direction, fourth direction will be in the y direction. Okay, first letter indicates the direction of the force, internal force, and second will be indicates the surface area of the direction. X direction, if you are going to take area in x and z direction, then it will be indicates the direction of the area. Okay, these all are the notations which we used to use in the theory of elasticity. To solve the solid bodies or continuum bodies, we used to use all these notation. These all are regarding the surface notations and surface forces which are acting in this particular body. Okay. With this I am stopping here now, and we will discuss other things in the next class, next lecture. Okay.